Let's get started. Hi, thank you for being here. So, welcome to my talk, Wait a Moment, How High Workload Kills Efficiency. But the more I think about it, I should actually have called it Getting Out of Quicksand with DevOps. But we will come to that. So how did I end up here? My name is Pickl, and for the last half year, I've been a technical project manager at Electrobit, which is an automotive software supplier. Before that, I was CTO of a medium-sized company in Vienna, but also a process manager at the Austrian parcel service. So sometimes I say I've been dealing with continuous delivery for the last 10 years. I have a background in IT and business. And CI, CD, and DevOps is the sweet spot for me, as I really love how the things I learned during my studies in production management and operations research are nowadays applied in the IT domain. Last but not least, I'm here to learn, so which means that I'm looking forward to the questions and also to the discussions afterwards, especially if your opinion and experiences differ to mine. In September this year, I was speaking at DevOpsDays Cairo, and Andrew Schaffer showed this slide during his keynote. It says, "I don't have time to learn new things because I'm too busy getting things done." And he quotes here the least productive person in the world. And that really resonated with me, because during that time I was also finalizing this talk, and I was reading Tom DeMarco's book Slack, which is really a cool book, and it also states that we are all too busy, and this not only kills our efficiency, but also our effectiveness. So being effective is about doing the right thing, while being efficient is about doing the things in the right manner. You are efficient when you do something with minimum waste. You are effective when you are doing the right something. It's possible to be one without the other. It's also possible to be both or neither. So for example, your car breaks down and you have a flat tire. If you now start cleaning your car or changing the wrong tire, you could be very efficient at this task, but it's still the wrong task, and it won't fix your car. On the other hand, if you change the right tire, but it takes you 2 hours because you don't really know how exactly it is working, and it takes you multiple attempts to do it, you are effective, but not very efficient. So we want to be both, but often we are neither. In his book, DeMarco also cites the evolutionary biologist Ronald Fisher, who says that the more highly adapted, that is efficient, an organism becomes, the less adaptable it is to any new change. So we really need to find the right balance and not over-optimize. The thing is, in my career, I found myself in a situation quite similar to the following multiple times. So I was part of a dev or ops team of 3, and the workload was not evenly distributed. Let's say I'm this guy, like working 100% of my weekly time, and often there's another one who's like the most experienced in your team, with his hair on fire and skipping lunches and working when he's ill and having lunch breaks at their desk and being the bottleneck. And maybe another one, this one, a more junior with some slack, but no one of the other have time to show him something, or they are holding on their dear tasks. So we are experiencing an overload situation, and we are showing symptoms of overload. For example, decreased team morale, working long hours or when sick, more frequent illness, unhealthy task use, and so forth. And then I noticed that the following discussions are getting more and more frequent. So I've changed the pictures here. We use different cat pics in our Slack, but other than that, it's more or less a screenshot. So the colleague says something, we really need to fix this XYZ hell. But you know, this really takes time. And then you ask them, how long does it take? And you're waiting like for an answer of like, I don't know, a week or a month or whatever. And they tell you, 2 to 3 days. And I'm like, what? 2 to 3 days? That's nothing. We should really do it. But it doesn't happen. And it hurts again and again. For example, we really need to use a static code analyzer, improve the deployment pipeline, introduce a better debugger, and so far and so forth. And I feel like this. I know that there is a better way of doing stuff. I've talked with friends with way more experience in the industry, and I've seen it at conferences like DevOpsDays Warsaw here. But we are just too busy. So who of you can relate to that? At least sometimes? Yeah, okay, some of you. So I go to my manager and ask him for support in DevOps testing, in the testing domain. And the manager says, you know, I don't know if you should really look for support in this area. Maybe you can just do some redistribution of work, and it will certainly take time to find someone. And you know, I'm not even sure if we were able to utilize that person up to 100%. But I'll talk to XYZ. There's someone in a different project, or if in a different team with a project on hold. He's working on 4 different projects. But you know, he's still got like this 20% that you need. And this is never going to work. And I'm like, the problem is that individual knowledge workers are not freely exchangeable. So I cannot take over the task of my colleague. And also, I don't want my team to be utilized 100%, because utilization is also not a good proxy for productivity. And the manager's like, what? And yeah, maybe we can talk about queuing theory. So queuing theory is something very interesting, but also quite hard to understand. So when I was preparing for this talk, I remembered that I studied long time for my operations research courses, and there are different types of queues. But let's start with the simplest one. For example, if you have a GG1 queue, which means you have a single server or actor, like a developer, and the inter-arrival times of his tasks have a general distribution, and service times also have a general distribution. The lead time of the system then heavily depends on his service time, his utilization, and variation in process and arrival. So this is also what the Kingman equation or approximation tells us. So if we assume that software development operations is a process with high variability, with a decent amount of task variability and variability in inter-arrival times, this applies. And I think it's quite sure that this is the case. Then wait time is related to the percentage of time busy by the percentage of time idle. So for example, if a resource is 50% busy, then it's 50% idle. The wait time is 50% divided by 50%, so 1 unit of time, and it gets multiplied by all this stuff. So on average, a task would wait in the queue for 1 unit of time, for example, like 1 hour. With 90% utilization, it would wait 9 times longer, so 9 hours before you even work on it. And this graph really depends on this term as well. So in a perfect world where the variability is lower, or where it is higher, this gets steeper, and where it's lower, it gets lower. So there's an inherent conflict between service quality and capacity management, with things deteriorating heavily at 70 to 80%. Of course, it's getting worse here, but here it's really like deteriorating a lot. And it's of course depending on the variability of the process. A similar idea is Little's law, which shows relations between the average lead time, the average work in progress, and the average throughput. But there are some important assumptions to it, and you can find more in the presentation from Daniel Vacanti that I put in my references. The important takeaway, so queuing theory is difficult, but the important takeaway is that you should focus on throughput rather than utilization. And if you reach high utilization levels, like here, all of your work will just pile up, and everyone will get very nervous, and will call for status meetings and additional planning, which adds work. So this really escalates quickly. You then reach a state that one of my colleagues in Vienna, Mario Kleinsasser, in a GitOps presentation at Vienna DevOps Security, referred to as quicksand. So the more you fight it, the more it pulls you in. Each time you try to put your leg out, it sucks you in again. But don't panic. So I really like this metaphor, and it stuck with me. And so I Googled how to get out of quicksand, and I was not disappointed because this could also help me in my day-to-day job. So you make yourself as light as possible, and I Googled this, so don't rely on it. Make yourself as light as possible, toss your bag, jacket and shoes, which could be like work in progress. Try to take a few steps backward, for example, to analyze the situation. Keep your arms up and out of the quicksand, so make sure that you still can act. Try to reach for a branch or a person's hand to pull yourself out, but make sure you don't pull them in. Take deep breaths, move slowly and deliberately. So I go to my manager again and tell him, you know, we really need more people, and all of them should only be utilized up to 80%. So they can invest roughly a day per week to spur innovation, rethink, practice new ways, master new skills, improve efficiency, and whatnot. And because that's how it is or has been done at 3M with their 15% time, and at Google with their 20% time. And what I really like is that at Google, they have their second SRE principle is SREs must have time to make tomorrow better than today. And I really like that one. So after all this research and listing all the pros, I have persuaded my manager, but it's too late. What actually happened is that we got even more to do, new projects, for example, and spent considerable time interviewing. It was quite unsure whether we would find someone. So the colleague, you know, the one with the hair on fire, just quit. He could not bear it anymore. So now me and the other team member also are under heavy pressure, and people under time pressure don't think faster. But at least we found a very skilled professional who starts today. It could be you. And given that you've just joined the team, you usually cannot jump right in. And the good thing is you might have some slack, at least in the beginning. So congratulations, you've just joined a team in an existential crisis. But that's not necessarily a bad thing. In A Seat at the Table, a book from Mark Schwartz, he says that transformational projects occur when the amount of debt has become too much to bear. So often organizations and also teams need to experience an existential crisis before they really take continuous improvement seriously. And the reason is that now a 10% change, for example, working overtime, is not enough anymore. You now need a 50% plus improvement. For example, you need an engineering solution. So if you can establish a sense of urgency, for example, we have to change how we work, a safe environment for failure, so things that were already late will now shift because your colleague quit, but we really need to try something new, and have the courage to question the status quo, which is maybe easier if you're new to the team or to the company. Crises are chances and opportunities to change things. I have an example, and I'm getting a little ahead of myself. So 3 years ago, I supported our ops team and asked how we deploy our iOS apps. So they told me, for each of the 5 variants of the app, check out the code on your local PC. Make sure you have the right Xcode version installed. Do these 3 manual changes. Select the right signing certificate, whatever that is. Compile, upload to App Store, enter, update all the relevant metadata, and wait for Apple to review the software. So for these 5 variants of the same app, it took like 1 day. And then I asked them, but what if the developer or the project manager or the tester find an error? And they said, yeah, you know, we have to start over. And this is so painful, we release very seldom. And we already asked the team for less releases, which are tested better. And I was like, sorry, I won't do it that way. It is 2015, at least back then, and there has to be a better way to do that. Maybe what was a good solution in the past is not today. So let's check. So being fortunate, 1 year earlier, I think 2014, Fastlane was released, which among others helps to automate the release process of apps. So we set up Fastlane with Jenkins in a way that by clicking a button, and that is something that the team or that the project manager could do, and waiting 20 minutes, everything was finished. So this took us roughly a week to get the first version up and running. And of course, it required some tweaking, but ever since, releasing iOS and Android apps, also Android apps, that's the cool thing, was a non-event, and we did it more frequently with the push of a button. So it really takes someone like you who questions the status quo. But where to start? I think first you should quantify the work. So what I like to do is something called activity accounting, where you allocate costs to the activities the team is performing to uncover non-value work. So you can do this based on your timesheets or look at your task boards. But you should not only watch for these categories, for example, unplanned work and rework, remediating security issues, working on defects and customer support work. I also think it's interesting to look at the things that you do not find or that you do very infrequently. For example, updates, releases, retrospectives, or you'll find that people are multitasking, which could mean that people are waiting for feedback. For example, because the build takes too long, or key people are not available to provide feedback. What I also like to do, and what really helped, is making the things your team is currently working on visible. So in my last company, we put up a monitor in front of our desks to the entry with our Kanban board, and everyone could see what we were currently working on. This reduced the number of interruptions. So they ask us, are you already working on X, Y, Z? And also helped to show that we had a lot of things to do, and if priorities differed, then people knew whom to talk to before bugging us. So in these numbers are from the State of DevOps report, Accelerate 2018. And you see that in the low group, so they put the people, like the companies in elite, high, medium, low, that in the low group you have 20% of unplanned work and rework and 15% customer support. So it could be that there is a quality or at least a documentation problem. What we also see in the low performers group, that they only spend 30% of the time working on new stuff, while the elite group is doing that for 50% of their time. So now you know what you're spending your time on, and you should set goals based on benchmarks. For example, you can benchmark yourself and see what you're doing here. But what takes so long? There is a saying that what gets measured gets managed. So you should measure your flow time, for example, lead time and cycle time, for the features you deliver. How long does it take your feature to go from commit to production, for example? Or how long does it spend time waiting in testing on the build server, between handoffs, or waiting to be released? You should also measure the frequency of deployments and your mean time to restore services. And there are also additional measures that you could take into account. But I guess it's important to get a rough indication and order of magnitude first, rather than trying to measure it with a stopwatch. What we also see is that work in progress is the biggest deterrent to flow. It's also a leading indicator. So the more work in progress is in your pipeline, the longer things take to complete. And that's what Little Law tells us also, at least on average. So if, for example, you could use aging reports and look for tickets that have not moved or have not changed status or haven't been updated in the last 30 days. On the other hand, we want to increase throughput. So what is the biggest bottleneck? Can we fix it? Can we bring the pain forward? For example, if releasing is very painful, can we do it more often? And you really have to ask why and investigate the root causes. Sometimes the fixes are quite easy once you know the problem. So I once worked on a project where the full cycle of building and testing took 26 hours. And releasing was a manual process which took me 1 hour of my time. But then I noticed that if our build cycle takes 26 hours and releasing manually takes 1 hour of my time, we should still, or I should still start fixing our build cycle first. Because even if that means that I may have to do the manual process more often in the beginning, I could also get a very good understanding of it and then automate the manual process in the second step. So I looked at the build time, and we were using Jenkins, and I looked at the console log and was trying to find out what took so long, and not all our entries had timestamps. So I installed the timestamper plugin for Jenkins. So this problem was solved, and I saw which step took most of the time. And I also found that the build was disk bound, so we really had an I/O problem on the build machine. Lucky me, there was a very small SSD in the build PC, which I used to run an experiment. So I shifted one of our builds, like the trunk build, to this small SSD, and immediately I saw that by building it on an SSD and not a hard disk, a 36% improvement. So I went to my manager and said, you know, this is like the 300, 400 euro that we should spend and get a 36 improvement in build times. So this is a no-brainer. What else happens is that if you are in an overload situation, there's a tendency to do more planning, but rather you should accept the uncertainty and appreciate the flexibility of software projects. So there is decreasing marginal utility of each hour spent planning. That doesn't mean you shouldn't plan, but the marginal utility decreases. Some authors even say that every hour spent planning is an hour not delivering, as resources often overlap. For example, the planning is done by your architects or your developers. You should come up with a lightweight capacity planning, for example, just a list of your initiatives, rank them, and do some high-level estimates. And then maybe you could even come up with a just-in-time approach where you add the details to these initiatives when you're working on them. And the important thing that there is only one most important thing. So let people know and avoid conflicting priorities. So less is more. And this is also something that you should take into account when looking at your work items. So you really should reduce working process and patch size. So stop starting and start finishing. This will also decrease context switching, increase focus, potentially reduce your cycle time. And sometimes you notice that you have a quality problem. So quality takes time. So a daring strategy is to reduce the quantity, and quality might go up. Also say no to additional work, or at least postpone it. Reduce variability and decrease predictability. That's what we saw in this queuing theory slide. For example, you could reduce the number of platforms. You could really push to kill some zombie projects that are highly unpredictable. Work on less versions or branches, for example, look into trunk-based development and fix the root cause. You should also do less features. So some studies show that 50 to 2/3 of all features are either never used or do not meet the business intent. What we also did is create a self-service platform. So in my last company, we set up a CI/CD platform using Jenkins. And if you automate everything, you come to the point where it doesn't really make a difference, at least in the normal case, who presses this button to release the software. So it changed from a matter of having time and the necessary skill to a matter of permission. So automate first, but first try to eliminate, doing less. So should we automate all the things? And the answer is no. But you really have to make time to create automation. So get management support, and if this is not possible, this may mean that you have to ignore or at least shift some of your current work items for some time. Documenting your process and making it repeatable is the first step to automation. So you should really automate, eliminate, or engineer out the drivers that are not key to the value proposition. New work is very hard to automate. Triage work, here automation helps for consistency, and repetitive work, this is where automation comes in and shines. So reduce your manual work, increase frequency, speed up the feedback loops, and the consistency then also leads to fewer errors. There are also additional benefits, but you should fix the biggest bottleneck first. Everything else make things worse and accumulate backlog. Remember that it may not even be a technical problem. Maybe just the person is overloaded. What I also liked about our automation and measurement effort is that we could sometimes reach win-win-win situations, or fixing a root cause fixed multiple problems. So for example, we noticed that our end-to-end tests run rather slow, so measuring them in detail revealed that we had a performance issue and a memory leak. And fixing this did not only make our tests run faster, but also helped us debugging faster with the faster software, and also our customers noticed a considerable improvement. There are different approaches to automation, and one is, for example, the leftover principle, where you automate as much as possible and humans do the rest. So you should always start with eliminate, then the rare, easy stuff you could still do manually. The easy, frequent stuff you should automate. The frequent, difficult stuff you should, for example, see whether there is an existing open source solution or an existing software that could help you with that. And then with rare, difficult ones, you could create tools, document, and then the things that you do very rarely and they are very difficult, you could, for example, get a consultant or hire someone. And there are also other approaches. But automation is not a silver bullet solution, and a word of caution is necessary. When the new automation is in place, there is less total work to be done by humans, but what is left is harder. And I've taken this from the State of DevOps report 2008 again, and they are drawing this J-curve of automations. We see that if you start in the low performing group, starting with automation really helps you, but then the automation increases the test requirements, which have to be dealt with manually, and you really have to invest to reach this state of excellence. So this requires spare capacity and slack. So you need to invest to be fast, and think of improvement activities as just regular work. So for example, if you use Fastlane to deploy iOS apps and it fails, then it at least took me at least a day to understand how signing iOS apps works again. So we have freed ourselves from quicksand, which as described is a vicious circle that pulls us in harder, the harder we try to resist. If you're not constantly working to improve, then by default, you're gradually getting worse. It's like the second law of thermodynamics, where the entropy just increases. But what's next? What we actually want to do is to establish a virtuous circle, which is a recurring cycle of events, the result of each being to increase the beneficial effect of the next. Okay, that was a definition, very hard one. So we need to establish a culture of learning and improvements that compound. Jess Humble, one of the authors of Continuous Delivery, for example, says lean works by investing and removing waste so that you can increase throughput. So prioritize the improvements that will do the most to improve flow. Start with the bottleneck, the biggest source of waste, fix it, and then identify the next bottleneck. And this is what is also discussed in the Accelerate book. They say here that improving your software delivery effectiveness will improve your ability to work in small batches and incorporate customer feedback along the way. Lean product management practices positively impact software delivery performance, stimulate a generative culture, and decrease burnout. Software delivery performance drives lean product management practices. It becomes a reciprocal model, or colloquially, a virtuous circle. This is from the Accelerate book. Also from the new SRE workbook, they say eliminating one bottleneck in a system often highlights another one. As each change cycle is completed, the resulting improvements, standardization, and automation free up engineering time. So engineering teams now have the space to more closely examine their systems and identify more pain points, triggering the next cycle of change. But this may be a complex problem and not only a complicated one. So you may not really know where to start, just what you want to achieve. And one experimental approach for product development, but also for process improvement, is the improvement cutter. So you get the direction of, or the challenge, and you don't know how to go there. So you grasp the current condition, and then you run some experiments to establish your next target condition. So you do the next step, and then you start over, you do the next thing, until you better understand what it takes to reach this challenge. Another tool which could help is to collect improvement ideas and prioritize them. And this may be very obvious, but some teams and organizations still wait for the like the high priority or high impact hard rewrite of their software or of the tooling, instead of now investing in the easy high impact change. So again, we want to create a virtuous circle where more release and test automation of improvements lead to faster releases and more time for new work, which then allow for more frequent releases, smaller batches, less work in progress. So you have fewer changes per release, lower lead time, fewer bugs per release, faster feedback, higher confidence, lower variability and rework. So now you now have more time to automate, and so it goes around and around. So you really have to speed up the feedback loop and reduce waiting times to get results faster. So taking this into account, in this situation I found myself in, we went on a journey of roughly 6 months to 1 year, and we really spent 20% or roughly 1 day a week to improve something. This may not have been the fix to the bottleneck in each and every case, but if not, it at least made the bottleneck more obvious. We also created self-service pipelines which reduced our workload. We used information radiators to reduce interruptions, and we set clear priorities and weekly goals. So we really had this headspace for improvement. So I want to conclude with a recap of things I talked about today. This is my experience, and as this is a complex or at least a complicated problem, your mileage will most likely vary. So crisis situations are opportunities for change. Never waste a good crisis. Often it takes fresh eyes or at least courage to see the problems. If you join a team and they tell you, yeah, you know, it had been that way for the last 6 years, this is not a good argument that you cannot change it. Get out of the quicksand. Maybe the sky is the limit. So quantify the work, set goals, measure, less is more. Automate, but automate the right things. Establish a continuous improvement process. And in the end, start a virtuous circle. And this is also in line with the 3 ways of DevOps, which is workflow, improve feedback, continue experimentation and learning. But also don't forget that it's people over process over tools. And if you want to know more about it, I can recommend you these books. All of them are great. But you can also look online for talks of the authors on YouTube, and I recommend you doing that. So I want to close with a quote from Domenica De Grande's book, Making Work Visible, which is also one of the books that I just showed you, which says, we don't let our servers get to 100% capacity utilization, so let's not do that to ourselves. Thank you for your attention. Some more references, and don't wait, get in touch. Thank you. Questions? Okay. There's one.
Hi, thank you. Thank you for your inputs. You mentioned a lot about measuring lead time, cycle time, gathering data. Could you tell us more about the tools that you are using to do that?
That's what I think you really shouldn't stop it with the stopwatch. But if you, for example, use Jira as a ticketing system, you could get that data easily. And also sometimes it helps to talk to your colleagues, but it's of course better to get unbiased numbers. Okay. Okay, then thank you.